Okay, so Unit 12 practice test. Um, here we go. How is dispersion different from dissociation? So they're both different ways to dissolve, along with ionization. All three are ways to dissolve things. Basically, with dispersion, what we have is we have covalently bonded molecules that don't get separated by the solvent. So if these here represent the water molecules basically come and they kind of wedge themselves in between and pry apart the covalently bonded molecules here. So this is like a sugar molecule because sugar is C6H12O6. So we've got our 6 carbons arranged in a rough hexagon, and that those hexagons get pulled apart, but they're whole. So they're pulled apart from each other, but they themselves are whole. So that is dispersion. And then these molecules get dispersed throughout the solution. With dissociation, we have something like when NaCl, table salt, is dissolved in water. So these are ionically bonded. So Na has a positive charge, Cl has a negative charge. The positive side of water, the negative side of water, since water is a polar molecule, is attracted to the sodium ions. The positive side of water is attracted to the chlorine ions, and basically those get surrounded by those water molecules, and then once they're surrounded, there's no more attraction between the sodium and the chlorine that are next to each other. They used to be associated, now they're dissociated. They're just going to float away as the molecules move, as the molecules are jiggling around and move apart. So that's the difference between dispersion and dissociation. So dispersion, the solutes molecules stay intact. Dissociation, the solutes molecules are pulled apart. I don't want to say pulled apart because these ones are pulled apart, but they stay intact. They're pulled apart into their components. When an acid is dissolved by ionization, it forms hydronium. So acids always start with an H. It's like HCl. That H reacts with the water to form hydronium, H3O. Okay, find percent volume. So percent volume, the formula is the volume of the solute over the volume of the solvent times 100. So 30 over 150 times 100%. So these cancel out. We get 1/5 times 100. 1/5 is 0.2, 20%. Find the percent mass. Percent mass is another way to talk about concentration. It's very similar to percent volume. We do the mass of the solute over the mass of the solvent times 100. So that's going to be 15 over 40 times 100. 15 over 40 is equal to 3/8. If you're a person without a calculator, which you shouldn't be on the test because I give you one. So 3 divided by 8 is going to get you 37.5%. Okay, how much potassium nitrate? Well, potassium is K, nitrate is NO3. So we're looking for KNO3 here. how much can I dissolve in 100 grams of water at 40 degrees C? So the chart, everything that I read off the chart is in 100 grams of water. If I increase the amount of water, or if I change the amount of water, I got to basically change what I'm reading off this chart by how much it changes. If I have 10 times as much water, if I have 1,000 grams of water, I'd have to take this and multiply it by 10. Oh, okay. So, potassium nitrate is KNO3. How much can I dissolve at 40? Well, I'm going up here, reading it off. I'm going to say 63-ish. Once again, I'm going to give you guys some wiggle room when you have to solve this. Okay, a solution of KCl. So a solution of potassium chloride is saturated at 10 degrees. So the solution has 30 grams of KCl in it. Then the temperature of the solution is raised to 100 degrees. How much more KCl can be dissolved? Well, at 100 degrees, I can dissolve that much KCl, right? 58? 58. So how much more can I dissolve? Well, that's 58 minus 30, which is going to be 28 grams. Because I'm just finding the difference in between these two. What's the lowest temperature that you can dissolve 35 grams of potassium chlorate? So I find 35 here on the chart. Go over till I hit potassium chlorate. It's like right here. I'm going to get, I'm going to call it about 77 degrees Celsius. Right? Right about in there, like 77, 78. Okay. Which salt has the highest solubility? So the salts are the ones that increase going left from right. The gases are the ones that decrease going left from right. So, hey, we have all these are salts. So the lowest, or the highest solubility at 10 would be NaNO3. So sodium nitrate. At what temperature can you dissolve equal amounts of NaCl and KCl? Well, I would just take a look at my NaCl line, which is right here. My KCl line, which is right here. And I want to find out where they cross. They cross right there. Boop, 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 boop. I'm going to say 27 degrees C. And then how much calcium chloride could you dissolve in 300 milliliters? Since that's 300 milliliters, I got to multiply by 3. Whatever I get off the chart, I multiply by 3. Because it's 3 times as much. Okie dokes. So calcium chloride, I got to find it here. Calcium chloride, boop. And at 20 degrees, it's going to be up here. Call it 77. That's going to be, so let's see, 3 times 7 is 21, so 210 plus 21 is going to be 231 Gs for grams. There we go. That wasn't that painful. Yeah, well,